Any questions?
Yeah. On the homework, number 51.
Sorry.
Let's see. Okay. Can you just do both A and B? Because A's answer is a little vague for me, and I just don't understand how they did it.
All right. So mu1 has a rest mass energy of 105.7 MeV. Indication to an electron in a massless particle. So we have mu1 gain an electron plus some massless particle. And we have an energy of 105.7 MeV.
What does MEV stand for?
Mega electron volts.
Okay.
If all the lost mass is converted into the electron's kinetic energy, find gamma for the electron. What is the electron's velocity? All right, so this is a massless particle. And so I am assuming that no energy goes into the massless particle based on all the lost mass.
Well,
Seems like odd wording.
in the solution, it just says like m sub naught divided by m equals like 206 something, and I just don't know how they got that.
Come on, 206.
Obviously. Because the explanation that the homework gives is energy is conserved, E subscript I equals energy final,
Right.
to arrow to energy sub mu equals E of the electron plus E massless particle, and then arrow to m sub naught mu c squared equals gamma m sub naught E c squared plus 0.
Okay. All right, so energy conservation. Because in the first semester course, if energy is conserved, that means we're dealing with kinetic and potential energies, and they get swapped back and forth between objects or transferred among themselves. We're now bringing rest energy into it. That I know that E equals mc squared. We did sort of a derivation of that, or E equals gamma m sub naught c squared. And so we are dealing with a particle that has a certain amount of energy, 105.7 MeV, and we need to get a conversion into something we can work with, equals gamma mass, the rest mass of the electron. So the rest mass of the electron, c squared plus, and we're assuming this has no energy. Sure. They didn't give us enough information to know anything about it. The fact that it's massless means it has no rest energy, but that doesn't mean it doesn't have energy. But we will assume for the sake of this, it doesn't. Mass of an electron,
Negative 1.6 thing.
that's the charge. I just saw it. Oh, wait. I know that this right here, because I have it written down in front of me, is 0.510998928 in EV.
So that's the mass of an electron times the speed of light.
Squared. Yeah. This is in units of 0.50, that number MeV per C squared as the mass of the electron multiplied times, it should be rest mass.
Okay.
But that's something you look up.
Okay.
So the math problem is 105.7 equals gamma times 0.510
That number.
1. And so gamma 105.7 over 0.511. I assume that's when you get the 20 whatever.
Yeah. That's what
Okay. And so that would be the value for gamma. And so then part B, the electron's velocity, well, properly it should be what is the electron speed, since we don't have a direction here, or magnitude of velocity. And I know gamma, of course, is 20 what?
26.84.
200.84
206.84.
is 1 over the square root of 1 minus beta squared. Solve for beta, and I know beta is equal to V over C, and so the speed would be beta times C.
And that's the answer for B. Part B.
Yes. Is that sufficient?
Yeah.
Okay. Other questions?
Are we gonna have one that is adding relativistic velocities?
Is there a problem in the homework set with that?
I don't think we've done it in class very, like a lot when I was looking about it.
All right, well,
Um,
let's do one. Or let's do two.
Number 22, I think.
Spaceship is approaching Earth at 0.1 times the speed of light. And a message capsule is sent toward it at 0.1 times the speed of light relative to the Earth. All right, I'm assuming yeah. All right, so it comes down to what is meant by toward it. Properly, that would be the speed. The message capsule is being sent towards the Earth, but it's quite possible that they meant towards the spaceship. But the antecedent, or actually, the antecedent is usually, it's the most recent noun, so capsule, but that doesn't make sense. So let's just assume that it is the capsule is being sent from the ship towards Earth. Earth. Capsule. Rocket or spaceship. Capsule being sent that way. And even though I've drawn it at a slight angle there, let's assume that it is in a straight line. 22, there we go. All right, so spaceship is approaching Earth, 0.1 times this. So I am assuming that the speed of the spaceship with respect to the Earth is 0.1 c. And message is sent toward it. So the speed of the capsule with respect to the Earth is 0.1 c. And so the question is, what is the speed of the capsule with respect to the spaceship? yeah, that can't be the correct meaning. All right, so here's how I know that this interpretation can't be right. I think the council has to be is towards the spaceship. Is that both of these objects, my first interpretation, both of these objects are heading towards Earth at the exact same speed. So how fast would it be going relative to the spaceship? Would be zero. Was that the answer?
No.
Okay, then I am assuming then that the capsule is actually being sent
At the spaceship.
towards the spaceship.
I guess that's what they mean by
Yeah.
it.
Yeah, well,
And
from
I
the
guess
people who brought you the year zero. All right, anyway.
That makes sense.
So, when adding velocities, I start with the Galilean. I know the velocity of c with respect to s. Put in some velocities here since direction will matter. Velocity of c with respect to s is the velocity of c with respect to the Earth plus the velocity of the Earth with respect to the spaceship. When I'm setting up vector addition here, it's always the velocity of the object with respect to the second object. And as long as those are the same, then the sum is going to be the velocity of the first letter with respect to that last letter. So since I'm looking for a CS here, I got a C and an S with a common in the middle. Now I have SE, I don't have ES, so I know this is the velocity of CE minus the velocity of SE. That's for a vector, negative just means, oh, the other way. And I have CE, I have SE. Now I have to worry about direction. Let's assume that, same with the velocity of the capsule with respect to the spaceship. Why don't we assume the capsule's moving in the positive direction? So that would be a negative. So I have 0.1 c minus negative 0.1 c. And now I bring in the relativistic aspects. 1 minus, same sign, 0.1 c, negative 0.1 c, divided by c squared. So I end up with 0.2 c divided by 1 minus 0.01, or 0.2 over 0.99 c. Whatever that is.
Should be 1.198.
I can do that. So 0.2 divided by 0.99. It's going to be something, though actually that will put it just slightly above 0.2. Oh, yeah. When I learn math, I get minus negative as plus 1.01. There we go. That should get us just slightly under 0.2.
1.98.
Or 0.198.
Yep.
That's a 0.2. I see.
So you see what you have, and then plug it into sort of that formula, the first formula you did, and then find the speed.
I think that pretty much sums up a whole lot of problems.
Yeah.
But I first look at it from a Galilean relativity point of view. Once I get into the form where I can start plugging numbers in, my numerator is whatever Galilean relativity says, and the denominator, those signs are the same. That and that, or those two right there, and divided by c squared.
So where do you get all that stuff in the formula? Like, where do you get that formula from?
We derived it. Not quite sure what you're asking, really. did the, I think throwing a baseball and a rocket ship, or something along those lines.
It's, so what's it called? The textbook used it different. I mean, the same kind of idea, but instead of like it was minus. Instead of minuses, you have minuses. It had pluses.
Okay. So, I mean, minus and negative, same as positive.
Oh, yeah. Okay. And then multiply. Yeah. Okay.
I personally, I find it easier to think about it this way, but, you know, different strokes, for different folks.
Word. Difference. Yeah, I'm right down with that.
The basis for the title of the TV show in the 70s. Other questions? All right, put a nail in the coffin of this thing.